We've now got a reasonable idea of how to work with Dart in at least a kind of limited capacity here. At this point, I feel like we're kind of limited by the restrictions of Dartpad. So we don't really have a lot of space to work here, and certainly even with this very small cards project, we still have to scroll around a lot to look at all of our code. So in this section, we're going to start to change that. We're going to install Dart on our local machine so that we can use our own personal code editor and start working on some more advanced projects. Now, I want you to know that the installation process for Dart is a little bit different depending on what operating system you're using. We're going to first pull up the installation directions for Dart, and then we'll walk through them together. So inside of a new browser tab, I'm going to navigate to dartlang.org. That takes me to the home page for Dart. I'm going to find the Install Dart link here on the right-hand side. If the home page looks a little bit different, and it totally might because they change the styling of this thing all the time, essentially you're looking for a Get Started page or a install or just something like that. So I'm going to click on Install Dart right here, and then we'll come to this selection. So in this course, you and I are going to eventually make use of Flutter. But for right now, we're just still doing some focus on Dart to get a better handle on the language itself. Installing the Flutter SDK is much more involved and is definitely a lot of work that we do not need to do just yet. So instead, we're going to start off a little bit more straightforward and install the Dart VM over here. The Dart VM is used to just run Dart code on your local machine. So I'm going to select Dart VM, and then it takes me to install the SDK. Now you'll notice there's a couple of tabs here. So you can select your personal operating system and then follow the appropriate directions. If you're on Windows, I recommend clicking on the Install Using a Setup Wizard link. You can click on this Dart SDK installer for Windows right here, and this is really important. When you go to this page that has the installer that you'll download and run, you want the dev version. So make sure you get the dev version right here. You do not want the stable version. We want the dev version down here. So go ahead and download that installer and run it. Now, if you're on Mac, we'll find this selection over here, and then we're going to go through this set of instructions instead. Now, the setup right here is going to be a little bit longer, so we'll take a quick pause right now. We'll come back in the next section and go through the Mac installation process together. So quick break, and I'll see you in just a minute. In this section, we're going to walk through the installation process of Dart on a Mac operating system. So if you're on Windows, continue on to the next section. Otherwise, if you're on Mac, stay right here. The Mac installation process is rather straightforward. It's just a collection of different commands we have to run. We're going to first get started by making sure that we have Homebrew installed on our local machines. To get started, I'm going to open up my terminal. So here's my terminal right here. You do not have to be in any particular directory, so just open up your terminal and that'll do. I'm going to first check to see if I have Homebrew installed. To do so, I will write out which brew, and then run that command. If you see a path like this right here appear on the screen, then you're good to go. If you see a message that says something like not found or just blank or no output whatsoever, that means you do not have Homebrew installed and you'll need to install it very quickly. To install Homebrew, we can find a link right here. You can either visit that link or you can open up your browser and navigate directly to brew.sh. Then at brew.sh, you'll find the installation directions right here. So you'll copy this entire link right here. You'll go over to your terminal and paste it. And then run that command. Now I've already got Homebrew installed, so I'm going to skip this step right here. Once you have Homebrew installed, we can then move on to step number 2, which is to run these commands. We're going to first run this brew tap command at the top right here. This tells Brew about the existence of the Dart project. So I'm going to copy this over and run that command. Now it might take this a second or two. I don't know. We'll see how long it takes. But while that's running, I'm going to flip back over, and I want to make sure this is really clear. Hopefully you're still listening. I hope this is really clear. We want to install the development channel right here. So we do not run brew install. No, not that one. Bad. Don't want that. We want the development version. So after you run the tap command, you're going to skip directly down to this command right here. You're going to copy it. You'll go back over to your terminal and you'll run that command, brew install dart --devel. So we'll install that and let it run. Now I've already got that package installed, so I get a nice little error message there. If you already have Dart installed, you can always run brew upgrade Dart to get up to the latest version as well. Okay, so after you go through that entire process, you might want to restart your terminal. Whenever you install Dart, usually it means that you've got to, or it adds an environment variable to your environment, or excuse me, it doesn't add an environment variable, it changes the path variable. And sometimes you have to restart your terminal to get that to kick in. So just to be cautious here, I'm going to close my terminal completely and then start it back up. And then once I do so, I should be able to run the command dart, like so, and see a big long help message appear. If you run the dart command and it says something like command unrecognized, well, that means that something went a little bit off during the installation process and we'll need to do a little bit of troubleshooting. So hop over to the QA section on Udemy and I'll do my best to help you out. Okay, so now that we've got Dart installed, let's continue on the next section and we're going to start talking about the next project that we're going to work on. In the last section, we installed Dart on our local machines. Before we start working on a real project, however, we need to make sure that we have a code editor that has good support for Dart. Now, we could definitely make use of just about any code editor you want to work with Dart, but there's definitely a couple editors that work better than others. I'm still here on the dartlang.org website. I'm going to go onto the left-hand nav over here and then scroll down and find the Tools section. Here's Tools right here. On the Tools page, you can find a list of IDEs that have some amount of Dart support. So the ones that have really good or very strong Dart support is IntelliJ, Visual Studio Code, and WebStorm. You'll notice that they make a plug for WebStorm right here. When I say plug, I mean to say they endorse it. They seem to really kind of push WebStorm right here. If you want to use WebStorm, totally fine. But in this course, I'm going to really highly recommend that you use Visual Studio Code. If you are already familiar with IntelliJ, great, go for it. If you already make use of WebStorm, totally fine. But if you've never used any of these three editors right here, I really recommend trying out Visual Studio Code. So that's what we're going to go through for setup inside this section. I'm going to show you how to set up Visual Studio Code for use with Dart. We'll first get started by visiting the VS Code or Visual Studio Code site. So you can access this by opening up a new tab, and you could do a simple search for VS Code. And we'll just find the first link on this page or on the Google search results. Here we go right here. So code.visualstudio.com. So we'll open up this page and you can find the download link wherever it may be on the screen. So you can download that installer and run it. The installation is just a little bit different depending on what operating system you're on, but I'm sure you can figure out how to install this editor. Now, as you're downloading this, installing it, I recommend you pause the video right now because on the next step, I'm going to expect that you've already got it installed. So feel free to pause right now. Okay, so assuming you're still here or assuming you came back, I'm going to assume you now have Visual Studio Code installed locally. We're going to do a little bit further setup with it. So I'm going to open up code on my machine, wherever it is, out of all these files that I've got. All right, I'll do it a different way. Here we go. So I'll open up Visual Studio Code. And then once it opens up, I'm going to find the View tab up here. So here's my View menu. And I'm going to select Extensions from it, because we're going to install an extension that gives us a little bit better support with Dart. So when I click on Extensions, I'll get this left-hand panel appearing. On the Search Extensions and Marketplace selection, I'll enter in Dart and do a search. So we're looking for a package called simply Dart right here. We do not need the Flutter one. If you see Flutter, you can ignore that. We're looking specifically for Dart. And then I'll click on Install. The installation will take just a second or two, and then after it runs, you'll notice that the Install button turns into a Reload button. So I'm going to make sure that I reload my code editor to get this extension to activate. And then once I've reloaded, that's it, I'm good to go. And I should now see Dart listed underneath the installed section. Okay, so that's really all there is for getting started with Visual Studio Code. So like I said, it is a highly recommended editor on my side. It makes life really easy for getting started, whereas using IntelliJ, a lot more heavyweight, a lot more going on there, especially on the setup side. So now that our editor is working, let's continue in the next section. In the last couple of sections, we installed Dart, and we also set up Visual Studio Code with a really solid Dart integration. In this section, we're going to start to talk about the next app that we're going to be building. This next app is going to be, again, focused on Dart, and we're not going to touch Flutter just yet. Dart is hard enough on its own, let alone tossing Flutter in on top. So we will get to Flutter eventually, but for now we still need to develop our Dart skills a little bit more. So with that in mind, let's take a look at a mock-up of the application we're going to build. So this is going to be a lot of fun, and I really think you're going to enjoy it. So we're going to build a command line tool application. So you can imagine this right here is like my terminal window, like the same kind of terminal we were using just a little bit ago. But we're not going to build any particular application. We're going to make an open source package that's going to help people make command line wizards of their own. So if you've never used a command line wizard, and I can almost guarantee you that you have, it might look a little something like this. We would prompt a user of some program to enter in a series of responses to some questions that we will ask them. So for example, we might ask our user who runs some given program, what would you like to do today? And then we'll prompt them to enter either a number 1 or a number 2. And so maybe today I want to learn about Dart, so I would enter in 1 and then hit enter. And then as soon as I do, I would be taken to step number 2 over here. So I get asked how much programming experience do I have? Maybe I'll say I've got 2 to 5 years. So I would enter 2 and hit enter. And then I would be automatically advanced onto the last step where it asks me, do I want to learn Dart for web? And I get prompted to enter yes or no, or Y or N really. And so I might enter Y to say, yes, I want to learn Dart for web, and then hit enter. So just to be clear, we're not going to make like this exact flow or this series of questions right here. Instead, we are going to make an open source framework to make it really easy to build command line applications that ask series of questions like this. After we make this open source package, we'll then use it to build our own very interesting little application. So this is going to be a 2-step project where we make the wizard asking framework, and then we're going to actually apply it in another project that you and I are going to build. So like I said, I'm really excited because it's going to be a lot of fun, and we're going to learn a lot about Dart along the way. So let's take a quick pause right here. We're going to come back to the next section, and we'll start to talk about how we're going to tackle this project. In the last section, we started talking about the next project that we're going to be working on. Just to make sure it's really clear, we're making a reusable library that will allow you to make wizard-type forms that run in your command line or inside of your terminal. So we're not necessarily going to be building something that just says, hey, what do you want to do today? We're going to instead make a reusable package that would allow you to build a question wizard like this. Okay, so in this section, we're going to start moving forward with this project by talking a little bit about how we work with Dart on our local machine. So up until this point, we've been making use of Dartpad, which kind of just has that one location to write code, and that's pretty much it, no other questions asked. But now that we're going to be making use of Visual Studio Code, or IntelliJ, or whatever you decide to use, we are going to be working with a lot of different files and folders. Dart projects have a very particular folder structure that are associated with them. So let's talk a little bit about some of the different files and folders that we're going to be creating to organize our project. Okay, so in this diagram, we've got a bunch of boxes here. Everything that you see in green represents a file. Everything that you see in blue represents a folder. Now what you see right here, this is kind of like a partial representation of a complete Dart project. So this is not an example of every directory that we might create, but it's the most important ones that you need to be aware of right now as we start to get started. Over time, we will add in a couple other files and folders to this mix as well. The other thing I want to mention is that this is a structure specifically intended for libraries that we might create. And right now, you and I are creating a library. If we were making an actual command line utility or a web application or a Flutter app, the directory structure right here would be just a little bit different. And as we start to work on those different types of projects, we'll definitely talk about how their folder structures actually are different. Anyways, let's get down to these files and folders. We're going to first start down here at the bottom. So this is a file that's always going to be placed in the root directory of our project. The file name is very special. It is pubspec.yaml. The pubspec.yaml file is kind of like the brains of our entire project. It records the name of the project, a short description, a list of all the authors who work on the project, and a list of dependencies. There's a lot of other information that we can store inside this pubspec.yaml file, but for the most part, that's what we're going to use it for: the project name, description, and recording dependencies. The pubspec.yaml file, like I mentioned, is a very special name, so we're going to make sure that we call this file exactly that, because there's a lot of tooling that we're going to work with that expects to see a file with exactly that name. The last thing I want to mention about this is that for our first project, you and I are going to create this file manually. But in the future, we're going to make use of some different command line tools that are going to automatically generate that file for us. Okay, so that's the pubspec file. We're now going to go up to the top here, this blue directory called example. The example directory is most relevant when we are creating a library, which is what we are doing here. You and I are making a library that's going to be able to be used in other Dart projects. The example library will contain at least one Dart file. So notice the extension here, .dart. We write Dart code into Dart files. The purpose of this example directory and this main.dart file is to contain an example of how we might use the library that you and I are creating. So you and I are making a library that will help people write command line utilities like this one right here. So inside that main.dart file, we might write up a very quick example of how to actually use this library. So if someone else wants to use it, they would have a very easy to read example, very clear on exactly how they make use of it. Next up is the lib directory. This is where you and I are going to do the vast majority of work on this first project. The lib directory has another folder inside of it called src. So there's a little bit of a difference between files that get placed directly into the lib folder and files that get placed into the src directory. Files that go into the lib folder, so like directly in the lib folder like this one right here, contain code that is meant to be shared with the outside world. Files that go into the src directory will contain code that is meant to be kind of closed off to just our library. So as a quick example, let's imagine for a second that you and I create some class to ask people questions, right? Maybe that's exactly what we're trying to do here. We're trying to allow people to ask questions at the command line. So maybe you and I write one class to make that happen. But maybe that class depends upon code that is spread over a collection of like 50 different files. So if that was the case, you and I would want to place that one class that other people are going to use to create form wizards inside of the lib directory directly. So this lib directory contains code that is meant to be shared with the outside world, or kind of used by people who are using our package or our library. The src directory is supposed to contain all the very private implementation details of our library that we don't want other people to kind of mess around with. Now, one thing to be really clear about, and this is something that we're going to really dive in deep on the object-oriented programming side, is that just a moment ago I said private implementation details. When I use the word private, I don't mean anything about security of our code. When I use the word private, I solely mean that if we want our library to work properly, we do not want people to mess around with code that is placed inside that src directory. So in other words, the src directory represents code that if someone messes with or someone tries to call a function or make use of a class that is defined inside this src directory, something is going to break in their program. Privacy has nothing to do with security of our code. Those are two kind of different concepts. And like I said, this is something that we're going to really harp on or drill down later on in the course as well. Okay, so that's kind of a brief overview of how we're going to generally structure our project. So let's come back to the next section, and we're going to generate or manually create our pubspec.yaml file to get started. So quick break, and I'll see you in just a minute. In the last section, we spoke about the general structure of Dart projects that are being used to create reusable libraries. We're now going to flip over to Visual Studio Code and start writing out our pubspec.yaml file. So I'm going to get started by opening up Visual Studio Code. I'll then go to File, Open, and I'm going to make a new folder that's going to house all the code for this project we're working on. So I'll go to some reasonable workspace on my local machine. I'll make a new folder, and I'm going to call this thing Prompter, because that's going to be the general name of the library that we're going to make. Prompter means we're prompting people to enter input into their command line. So I'll create that folder and then open it. Now after just a moment or two, I should see my File Explorer appear on the left-hand side. If you don't see this, you can always go to View and then hit the Explore option right here. So when we first create this project, we get absolutely no files and no folders. We'll first begin by creating that pubspec.yaml file, and we're going to put together just a little bit of configuration inside there. So I'll click on the New File button, and then I will make a pubspec.yaml file, like so. Remember, the name of this file is very special and very important. So we do not want to change the name from anything you see right here. We want exactly pubspec.yaml. Then inside of here, we're going to put down a little bit of project configuration. We'll first start off by writing out the name of our project. So I'm going to call mine prompter. I'm also going to put on an underscore and put my initials of SG. So the reason I'm doing this right here, putting in my initials, is that eventually you and I are going to push this project to a central repository of packages. And you and I are going to use this library on another project that we put together. That central repository can only have one library with a given name. So if someone else out there has already used the name prompter, well, then we're out of luck and we would have to rename our project. Now, given that you and I are creating this library as part of a course, and chances are other people will be taking this course as well, chances are someone's going to take this name right here. So in short, I just want to have a reasonably unique name so that when we go to push this project later on to that central repository, we don't get some error message saying that this project name is already in use. Okay, so that looks good. Now, just to be clear, again, you probably don't want SG because I'm already using this one. You could put any random string on here. It really doesn't matter. Just make sure you've got some reasonably unique string there. Then underneath that, we'll put down an initial version of this package, which will be 0.0.1. It is our first version. And then we'll put down a quick description as well. And we'll say library to create CLI wizards, like so. Okay, so that's a reasonable place to get started. Let's take a quick break. We're going to come back in the next section, and we'll start to create some of these other files and folders. In the last section, we put together our pubspec.yaml file. We're now going to work on our example directory. Remember, this example directory is only used for projects that are creating libraries. Inside that directory, we're going to place a main.dart file. And the purpose of this file is to serve as kind of a demo of how our library is used. As we develop our library, we're going to be using this main.dart file to test out the code that you and I are writing. So let's get to it. I'm going to open up Visual Studio Code again, and inside of my root project directory, I'm going to make a new folder called example. Then inside that directory, I'll make a new file called main.dart. Now before we go any further, if you're using Visual Studio Code, there's something that I want to point out to you, because this might save you a lot of headache later on. I want you to notice something really quickly here. On this Explorer panel, if I click like down here, you'll see this kind of faint orange line appear. So that means that I've got my root directory focused right now. If I then click on this new file button, it creates a new file inside of my root directory. But if I instead select the example directory, so like I click on that and it kind of highlights itself, and then click on new file, a new file is instead created in the example directory. So if you're going to use this new file button right here, just be aware of where the file is actually being created, because this is something that you can really easily later on create a file in the wrong directory. And like I said, that's just going to lead to a world of hurt. So in this case, let's double check right now. We definitely want to make sure that this main.dart file is placed inside the example directory, okay? Okay, so now inside the main.dart file, we're going to write just a little bit of code to make sure that our entire setup is working properly and we have the ability to execute Dart code. So inside the main.dart file, I'm going to write out a main function, because remember, this is the one function that we always have to define for our Dart program to run successfully. And then inside there, I'll write out print hi there, like so. Now, as you type out this code, I'm sure you're able to notice that we get some really quick feedback here, giving us some autocomplete, and if we have any invalid code, like this right here, we get that little squiggly red line that tells us, hey, here's what's wrong with your code. So we're going to be taking advantage of that quite a bit as we work on other programs inside this course. Okay, so I'm going to go back to print hi there. I'm going to save this file, and then we're going to flip over to our command line and figure out how to execute this Dart file. So I'm going to go back over to my command line, and I'm going to change into the directory that you and I just created. So here's the prompter folder that we just made. I'm going to change into that. There's the example folder that we just made. I'm going to change into there. And now I can see very easily the main.dart file. So to execute this file and run all the code inside of it, I can run dart main.dart like so. So if I run that, I'll then see hi there printed out at my terminal. This dart main.dart command right here, we're going to run it probably, about 1 billion times or so throughout this course. So we're going to get a lot of practice running this command right here. This is how we run Dart code from the terminal. Okay, so in this section, we got started with a little main.dart file. Remember, this file is going to eventually serve as a demo of how to use our library. As we are building out our library, you and I are going to write a lot of temporary code in here just to get a better sense of what's going on with the library code that we're putting together. All right, let's take a pause right here. We're going to come back to the next section, and we're going to start thinking about the overall design of our program. So quick break, and I'll see you in just a minute. In this section, we're going to start thinking about the overall design of our library. We're going to be using the same flow that we had used previously on our deck of cards application. We'll first start off with this question where we ask ourselves what type of things exist inside of our app. And then we'll go and create a separate class to represent each one of those things. When we applied this question back inside of our deck of cards application, it was a pretty easy question to answer. There was some actual physical representation of the things we were trying to model. In other words, there was kind of a physical card that we could imagine. And if we took a bunch of those cards and put them together, it formed a deck. So there was a very clear mapping between the kind of abstractions inside of our program and the actual physical world. So answering this question right here was not that bad. But this time around, there's much less of a physical mapping right here, and it's not quite as clear what things or what kind of physical things we can kind of imagine exist in a program like this. So in this section, I'm going to show you a diagram that's going to lay out one possible way of kind of interpreting this application right here and saying what different things exist inside of it. Now remember, anytime I show you a design for a program, it's not necessarily the best way or the right way. Everyone comes up with their own personal design for an application. And so if you think of a different way to implement this, that's totally fine. Okay, so let's now take a glance at a diagram that's going to help lay out my personal thinking in how we might represent the different types of things that exist inside of a kind of terminal wizard kind of deal here. Okay, here we go. So in this diagram, we've got a flow of a couple of different people. Each of these people on here are going to eventually kind of represent a class, but let's go through the diagram and I think you'll get a better sense of my thinking. So we're going to start off here on the very left-hand side. Let's imagine that maybe you are a developer or this person is a developer and they want to ask a group of users or a particular person a multiple choice question. But this developer right here is maybe very shy and they don't want to directly interact with a person. So maybe this developer puts together a question and a possible list of answers. And then they hand it off to a professional polling firm, a company who's really good at taking a question and a list of possible answers and somehow getting feedback on that question and those answers. So this professional polling firm right here, maybe they themselves do not actually take the question and go out to the street and ask people the question. Maybe the professional polling firm works in a really big building that's in some secret far-off location and they don't really have the ability to ask people directly for feedback about this particular question. But they do have the ability to take that question and the list of answers and kind of format it in a nice way and kind of make sure that they can facilitate the entire process of asking the question and then giving some feedback to the developer over here. So although this professional polling firm can kind of facilitate the entire process of collecting feedback, they're not going to interact with a person directly to ask the question. Instead, maybe they're going to hire someone of their own, someone over here, and maybe that person is really, really good at telling someone something or just presenting some information to some outside party via the terminal and then seeing what response they get back. So the professional polling firm right here is kind of a facilitator of the question asking process. And the person over here on the far right-hand side is an actual person on the streets asking people questions and collecting feedback. Now, you might immediately think, Steven, okay, like I kind of get this, but why is there a difference between this polling firm right here and this person right here who actually goes and asks questions? Why don't they just kind of merge together and form one entity? Well, I want to point something out to you. Notice how this person right here is really good at asking questions at the terminal and collecting feedback. Maybe we want to eventually make sure that our program also has the ability to ask for feedback or ask questions and collect feedback over some completely different medium, like say the internet. So maybe there's one person out there who's really good at communicating via the terminal, and then there's someone else out there who's really good at communicating via the internet. So merging together this kind of question asking facilitator along with a person who actually asks the questions might not be the best plan, because we might eventually want to have different people who ask questions and collect feedback over different mediums. So that's why I decided to split these out into kind of two separate entities. It allows us to maybe switch out this code for something else in the future and still be able to facilitate the question asking process, but present the question and collect feedback in a completely different way. Okay, so I know we're kind of getting into the rabbit hole here, so let's kind of bring this through and talk about the real design that we're going to come up with. So if you kind of buy into this flow right here, you might end up with a collection of classes that look like this. Maybe on the left-hand side over here, our developer, like the person who wants to ask a question, is going to create a list of options. And an option represents one possible answer to a given question. So on this question right here, we've got the question text at the very top, and then we would have option number 1 and option number 2. And so I think that we should create an option class that represents every option that's being presented. The reason that we might do a class here is that we might want to eventually have some code tied to each possible option. For example, if someone selects number 1, we might want to execute some custom logic. But if someone executes option number 2 or selects option number 2, maybe we want to execute some completely different logic. And so by turning these different options into a class, it's going to give us some flexibility in deciding what happens based upon a user's decision. Okay, then we'll move on to the next part. So this professional question asking person right here, kind of the facilitator of sorts, we're going to refer to as the prompter class. So the prompter class is going to be an object that can take a question and a list of options or possible answers and make sure that that gets somehow eventually presented to the user, and then route some feedback back over to this developer and say, hey, here's how these people answered that question. And then finally, the prompter is going to rely upon something that we'll call the terminal class. The terminal class is going to be responsible for actually taking this text, like this very real text that needs to be presented to the user, and making sure that it gets printed out to the terminal. And then that terminal class will also be responsible for waiting around for some output to come back and make sure that it takes that output and communicates the decision or the response back over to the prompter. And then the prompter can communicate that back over to this developer. Okay, so that's the general idea. That's just one possible way of laying this out. And I kind of did my best to kind of, give you an idea of my thinking here, of why we divided this into 3 separate classes. So in total, we're going to have the option class that represents just a single answer to a question. We're going to have the terminal class, which knows how to print out a question and receive some input back. And then finally, we're going to have a prompter class that kind of ties those two things together and facilitates the process of actually getting that question printed out on the screen and then getting that feedback to the developer so that they can execute some code inside their program. All right, so I know this has been a long section, but I hope it's been helpful in explaining how we came up with this particular design. So let's come back to the next section and start putting this implementation together. In the last section, we spoke about one way of designing our application. So we're going to have 3 separate classes: the terminal class, option, and prompter. In this section, we're going to get started by creating a different file for each of these classes, and then just defining them. We'll then first start off by working on our terminal class a little bit so we get a better idea of how to work directly with the command line and print out information and receive information entered by a user. So I'm going to get started by changing back over to my code editor, and then inside of my root project directory, I'm going to make a new folder called lib. And then inside of that lib directory, I'll make a new folder called src. So remember the directory structure that we spoke about just a little bit ago? Inside the lib folder is all the code related to our library project. Immediately inside that file is going to be code that we want to share with the outside world. And then inside the src directory is going to be private code that is only concerned or really used by our library. We're going to create all three of our classes inside this src directory, and then we're going to come back later on inside the project and make this more public file. So we're going to take an approach right now that's just going to kind of get us started and get us working, and we'll come back later on and make things a little bit more clean and follow this pattern a little bit more closely. All right, so I'm going to flip back over to my editor, and then inside of that src directory, we're going to make a couple of different files. I'll first make the option.dart file. So this is going to hold our option class. At the top, I will immediately declare this new class, so class option, like so, and I'll just leave it like this for now. I'll then make a new file inside my src directory. I'll call this one terminal.dart. As you might guess, this is going to hold our class terminal. I'll save that file, and then one more time, I'll make a new file for the prompter, and I'll make class prompter inside of there. Okay, so we've now got three files inside of our src directory. I want to remind you that if you use this new file button right here inside of VS Code, where the file gets placed depends upon which file or folder you have focused. So please triple check to make sure that inside the lib directory is the src folder, and then inside of src is all three Dart files that we just created. Okay, so now that we've got some code put together, let's come back to the next section and we'll begin working on our terminal class. In the last section, we created a couple different files inside of our src directory. I've now got my terminal class open right here. In this section, we're going to spend a little bit of time to think about the different methods and fields that we might want to attach to this terminal class. Remember, the terminal class is responsible for printing out information to the terminal and then receiving input from the user whenever they enter a key and press enter. We'll first get started by going back over to the mockup of how we want to eventually have our library be used. So remember, we want to print this stuff out at the terminal. Now, as I start to look at this mockup right here and some of the others that we put together, I'm kind of noticing a common theme between each one. I notice that at the top of every kind of slide here, we've got some prompt that's being displayed to the user. So at the very top, we're always displaying a question of sorts. And then immediately underneath that, we present a list of all the options to the user. So prompt comes first, and then we print out a list of options. Now the other thing that this terminal class is going to have to do is somehow collect the input that a user enters at the prompt down here. So if they enter 1 and hit enter, or whatever else it might be. The last thing I want to point out about this terminal class and kind of these different mockups that we're looking at is that you'll notice that every single question that we're posing right here appears to be kind of on an empty slide of sorts. So I think that it would be kind of neat if anytime we prompted a user to enter some information, we cleared the entire terminal window and displayed just the question and the associated options along with it. So in other words, if I go over to my terminal right now and I had a single question over here, something like, hey, enter your favorite food or whatever, and then a user answers that and we move on to the next question, I would want to clear everything that's inside of here or everything that's in the terminal and only display the next question. So in total, I feel like maybe there's 4 different things that this terminal class needs to do. I kind of feel like maybe we want to have some function tied to it that's going to print out the prompt to our user. I think that we might want a method tied to it that's going to print out all the different options that the user can select. I think we might want to have some method to attempt to collect some input from the user, so detect a key press and then the enter key as the user tries to select an option. And then maybe we should also have a method that attempts to clear the entire terminal window. And we'll call that thing anytime we're about to display another question on the screen. Now, the last thing I want to point out here is that it really doesn't feel like there are any pieces of data that are associated with the class. All the options and the questions that we're asking are going to be handled by this option class and the prompter class. The terminal itself doesn't really seem to have any kind of persistent information tied to it. So I'm thinking that for the terminal class, we may not have any fields whatsoever, and we'll just have this collection of methods instead. Okay, so this is kind of an initial design take on some of the different methods that we're going to put together. Let's come back in the next section, and we're going to start figuring out how we're going to implement each of these functions. So quick break, and I'll see you in just a minute. In the last section, we spoke about the implementation of the terminal class. So we said that we're going to have 4 different methods tied to it. In this section, we're going to get started on this print prompt method. So I'm going to get started by flipping back over to my code editor and opening up the terminal.dart file. Then inside of this class, I'll open up the body, and I'll define the print prompt method by writing out print prompt, like so. The sole purpose of print prompt is to take a string and print it out to the terminal, specifically to handle this kind of like header up here at the top. So since that's its only purpose, I really don't expect print prompt to have to return any value. In addition, I really think that we're going to have to call this method right here, or call the print prompt method with a string that we want to actually show on the terminal. So with that in mind, I'm going to go back over to my code editor, and I'm going to put the word void before the method name. The void keyword right here means that we do not intend to return any value from this method at any point in time. Then, to receive the prompt as an argument to this function, I'll add it in like so. Now, if I hover over print prompt right here, you'll notice that in that little tooltip that I get, it's marking prompt as being of type dynamic. And remember, dynamic means essentially any type. So right now, we could call this print prompt method with any type of value that we want, which is probably not ideal because we wouldn't really want to call print prompt with, say, like an object of sorts, or an image, or who knows what else, an HTTP connection, or some other weird type of value. We specifically want to call print prompt with a string that can be printed out to the terminal. So I'm going to make sure that I annotate this argument's type as being string. So we've now given Dart enough information to understand that you are only able to call print prompt with a string. And if I now hover over this again, it's very clear that Dart understands that is the case. Okay, so good start. Let's come back to the next section, and we're going to figure out how we're going to take this argument and get it to show up in the terminal. In the last section, we started putting together our print prompt function. Our goal is now going to be to make sure that this function takes this argument right here and gets it to show up inside the terminal anytime we run our program. Now, we've kind of already printed stuff out to the terminal before. In fact, we did that just a couple videos ago when we created this main.dart file inside of our example directory, and we called the print function inside there. So you might be thinking we could reuse this print function inside of our print prompt method right here. That's definitely a valid option to go. It's definitely something we could do. However, the print method is really associated with debugging Dart programs. We usually use that print function when we are trying to print out a value for the purpose of solely debugging our code. If we're not debugging our code, then we traditionally use a slightly different method for writing information out to the terminal. So let's go pull up the Dart documentation and get a better idea of what function we're going to be using instead of print. All right, so I'm going to open up my browser. I'll make a new tab, and I'm going to pull up the API for Dart again. So remember, we can get there by going to api.dartlang.org. Okay, so on this page, remember that depending on when you take this course, version 2 of Dart may or may not be in its final release stage. So if you see this page right here, you're going to want to find this blue link to go to the version 2 documentation. If you're already on version 2, then that's fantastic, you're all set. All right, so on this page, we've looked at this documentation before. On the left hand, we've got the list of all the different libraries that we get access to. Now before, we were looking at some of the documentation inside of the modules in this first section right here. The modules that you see listed out right here are available on every single platform that we run Dart code on. So we can use these libraries if we are running code on our machine directly from the terminal, or if we're using it to build a web application or anything else. But if we want to use code specifically for working on the terminal, we're going to look at some of the libraries under this VM section right here. So because we are working with Dart on our personal machine, writing a command line interface utility, we get access to not only the entire base library right here, but all these additional modules marked as VM as well. So one particular library that's going to be very useful for us in this application is the Dart::io module. So I'm going to open up the docs for this. And then on the Dart::io library page, I'm going to scroll down just a little bit. So scroll, and I'm looking for a section called Standard Output, Error, and Input Streams. So this is the function, or this is kind of the group of objects that we're going to use to actually get information out to the terminal. I want to give you a quick aside on what the terms standard output and input mean. Okay, so quick diagram here. So this is our program in blue down here. Anytime you and I want to write information out to the terminal, and that is like the actual purpose of our program, we're going to be making use of this standard out object. Standard out is the object and the function that we use for writing out information to the terminal when that is the purpose of our program. If we are writing information out to the terminal for the purposes of debugging, we're going to instead make use of that print function. In order to get information from the terminal back into our program, we're going to use a slightly different object referred to as standard in. So this standard out and standard in objects are how we communicate with our terminal. All right, so I'm going to go back over the documentation here. So you can read a little bit about standard out and standard in right here. You'll notice that they've got a quick example of how to write information out to the terminal using the standard out class right there. And then if we want to, we could also use the classes section on the right-hand side here. I'll scroll way down to standard out right here, and I can open up this section and take a look at all the associated documentation as well. So the method that we're going to use in particular for getting information out to the terminal with the standard out class is listed at the very bottom of this file. So I can scroll way down to the bottom and I'll find something called write_ln, which is short for write line. This is a method tied to the standard out class that we can use to simply print information out to the terminal. So essentially, it's completely identical to that print function. There's a couple of behind the scenes differences with this standard out thing that make it more appropriate for using it as the primary means of communication over the print function if this is the goal of our application. Because remember, we use the print function primarily when we're doing debugging. Okay, so in this section, we took a look at some of the documentation around this standard out class. Let's continue in the next section, and we're going to get this class hooked up to our terminal.dart file. In the last section, we looked at the documentation for standard out. So this is the class that we're going to use inside of our terminal file to communicate information over to the terminal. Now the next thing we need to do is to figure out how to actually make use of this standard out thing inside of our terminal.dart file. So I'm going to show you a quick diagram. All right, so over here. So this is kind of representing our project as it stands right now. On the left-hand side is all the code for our application. Inside of our app, we currently have that terminal.dart file. We've got a couple other files inside of our project right now, but they're not super relevant right now. In order to make use of any of these standard library modules over here, like say the Dart::io one right here, we have to form a distinct link from our file over to this Dart::io module. To do so, we're going to use the import statement with Dart. By adding in an import statement inside of our terminal.dart file, it's going to form a link between both these files, and it's going to give us access to all the code that exists inside of this Dart::io module. You'll note that we did not have to go through any import steps before when we were making use of Dartpad. That was because previously we were making use of the Dart core module, and we were looking up documentation in Dart core. You get all the implementation of Dart core for free, and you don't actually have to form up a connection when you're making use of it inside of Dartpad. So it's only now that we are inside of our own code editor in a more serious environment that we have to start worrying about these import statements and linking this Dart::io module up to our terminal.dart file. So let's flip back over to our code editor and we're going to form this connection right here. So to form that connection, I'm going to go up to the top of the file, so the very first line, and I'm going to write out import Dart:/IO, like so. Now when I do that, you'll notice that my text right here turns green, or I get that little squiggly of green underneath. And if I hover over that, it says unused import. So remember, Dart wants to make sure that you actually make use of any variables that you create inside of your application. And the same goes for import statements as well. So if we import some module but don't actually make use of it, Dart is going to complain just a little bit and say, hey, you probably don't need to actually import this thing. Now the next thing I want to tell you about is what actually happens when we add in this import statement. By just writing import right here, it adds all the contents of this IO module right here to the scope of this file. So that means that now inside this file, I can get access to every single class that exists inside of the IO module. So if I go back to the IO documentation, so here's the IO library, I can now access every single one of these classes right here by just writing out the name of the class. So for example, you see bytes builder right here. Inside of my print prompt function, I could freely write, what was it? Bytes builder. And you'll notice that the autocomplete kicks in for me. And so that's a class, so I could try to call its constructor. And by just referencing bytes builder, hey, no problem. It's now inside the scope of this file solely because we imported the IO module. Now this might be a little bit of a surprise, because essentially what happens when we add in this import is we now get all these additional variables added into the namespace of this file right here. So if you and I had already defined a class inside this file called bytes builder, and we just didn't know that there was a conflict there, well, this local implementation of bytes builder is going to override the one that we just imported. So you'll notice now I get that green squiggly back and it says unused import. So this is something that's extremely misleading because we are no longer using the bytes builder that was imported by the IO module, and we're instead using this local implementation of it. And you would kind of hope that Dart would tell you about that. You'd kind of hope that it would say something like, hey, you already imported something called bytes builder, but you just overwrote it. But it's not going to do that for you. So it's a little bit of something to watch out for. Thankfully, the name of classes inside of here usually are things that, you're going to kind of keep in your head over time. So I just want you to be aware of the fact that you can kind of clobber classes that have been defined inside of a module that you are importing. Now, another way to address this issue is to import this module right here and namespace all the classes or all the objects, all the values that get imported with that module. So we can do so by writing out the import statement, and then at the very end we can write as IO, like so. So now all the modules that are contained inside the IO module get assigned to a new variable called IO. And then we could freely reference this IO variable right here anywhere inside of our code. So right here, rather than trying to create bytes builder, I could write out IO, so that references everything inside the IO module, dot, and then I can make another bytes builder, like so. And this time, I'm referring to the bytes builder that is included in the IO module, and not the local one that I just created right here. Okay, so just a little bit on modules and import statements. Throughout this course, you and I, for the most part, are not going to use this kind of namespacing syntax right here. No good reason for that. We absolutely could. We're just not going to be naming a lot of classes that are going to clobber with existing classes that exist inside of our modules, but it's certainly something we could do. Absolutely, positively. We could definitely namespace these modules and not have to worry about clobbering anything. But for our purposes, I've done the homework for us. I know that this is not going to be an issue, so we don't really have to worry about it too much. Okay, so we've now got access to all the modules, all the classes, inside the IO module. So let's take a quick break. In the next section, we're going to come back and make use of that standard out class inside of our print prompt method. So quick break, and I'll see you in just a minute. In the last section, we imported the IO module into our terminal.dart file. So we're now ready to make use of standard out inside of our print prompt method right here to print out the prompt that is passed to it. Now, before we make use of standard out, there's just one last little gotcha I got to tell you about. And this really is a gotcha. I apologize for it, but we'll get through it pretty quickly. So let's talk about what the gotcha is. So I want to pull up a diagram we were looking at just a little bit ago. Back over here, we had said that we were going to make use of that standard out thing to essentially get some information over to the terminal. Now, anytime our program starts up and connects to this terminal right here, we get access to essentially one channel of sorts that receives input from the standard out object inside of our program. So when you kind of think about it, there's not really a lot of utility inside of our program to create multiple instances of a standard out class, because at the end of the day, they're all going to be printing to the exact same terminal. So we wouldn't really have a lot of functionality or a lot of benefit to creating multiple instances of that standard out class that we just saw inside the IO module. So remember back over here, we scrolled down on the right-hand side and found standard out right here. So in other words, there's not a lot of benefit to creating multiple instances of standard out because they're all communicating over the same channel over to our terminal. So when you take that into account, the authors of this Dart IO library right here decided to save you and me just a little bit of time. They said, hey, you know what? Rather than making you have to create your own instance of this standard out class right here, we're going to just automatically create an instance for you and make that instance available. So rather than you and I trying to make all these useless extra copies of standard out that are always going to shove information over the same channel over to the terminal, the authors decided to make an instance of standard out available to us for free. So if you scroll all the way down on this right-hand panel to the very bottom, you'll notice that on this properties section, there's a property listed here of standard out, and it's in lowercase here. So the lowercase indicates that this is an instance of standard out that has been already created for you and me for free. So if you look at the documentation for this thing, this text right here means that the standard out property on the IO module is an instance of the standard out class that has been already created for us. So all I'm trying to say here is that back inside of our code, you and I do not have to do something like standard out equals new standard out. This has already been done for us. All we have to do is reference the standard out property that is available to us for free by the IO module. Okay, so now that we've got that down, that's the gotcha. You know, this thing has already been done for us. Usually we have to create instances of classes. This is just one time when we do not have to go through that step. So now that we have referenced this thing right here, we're going to get access, or we're going to call that write line function that we just looked up on the standard out documentation. So really quickly back over here, I'll go back over to the standard out class documentation. Here it is right here, and then down at the very bottom, we were looking at that method called write line or write ln. And that's what we're going to call to actually get some information printed out to the terminal. So inside of our print prompt method, I'm going to reference the standard out property that's coming from the IO module. I'm going to put a dot in and attempt to call the write ln method. So here it is right here. You'll see my autocomplete is kicking in. One thing to take special note of is this is not a capital. It's a lowercase ln. So we're going to call write line right here, and we'll pass our prompt directly into it. Okay, so that was a lot of lecturing just to get a kind of print statement put together here that's essentially doing the same thing as that print function. So I know this might have been a little bit frustrating, but everything else we're going to write inside this file is going to go much, much faster than what we just did. So the last thing I want to do here is a quick test of the function we just created. So let's take a pause right here. We'll come back to the next section and do a quick test of the print prompt method. So quick break, and I'll see you in just a minute. In the last section, we finished up our print prompt method right here, and we're now ready to test it out. So to test it, we're going to add a little bit of code to our example main.dart file. The first thing we're going to have to do is to form a connection between the main.dart file and the terminal.dart file in exactly the same way that we just formed a connection between terminal.dart and the IO module. So remember, anytime we create a Dart file inside of a Dart project, it essentially exists in isolation. To make use of the code inside of any given file, inside of another file, we have to form a link between the two, and that is done by using an import statement. Now we just went over all this stuff by importing that IO module. So you might be thinking, okay, Stephen, whatever, let's just write the import statement, get it over with. Well, unfortunately, like most things in life, it's not quite that simple. So this is kind of, in my opinion, a sore spot around Dart, at least in terms of learning it. Okay, so this import statement that we're going to have to write is going to be a little bit complicated when you first learn it. But once you learn it, it's going to make a lot of sense, and it's actually a pretty good mechanic. So let's do our best to figure out what's going on here. So what I want to point out to you in particular here is that the importing that we're doing is very different than what we were doing before. Before, we were inside of our terminal.dart file, and we were importing a standard module. Whenever we import a standard module, we write out very simple import statements like the one you see right here. When we import a file from anywhere outside the lib directory into, or you know what I mean, from a file that is in the lib directory into not the lib directory, things get complicated. So let's take a look at a diagram that's going to help you understand these different import statements. Okay, here we go. It's a kind of crazy diagram. Bear with me here. We're going to start off on the first row up here. So this is the type of import statement we would write if we are getting something from the Dart standard library. This is the easy case right here. So if we are importing a Dart module, we simply write out the word import, Dart, a colon, and then the module's name. So IO or collection or core or whatever else it might be. Now let's look at a second case. This is a case that we are not in yet. So this is not applicable to us just yet, but it will be very shortly. The reason I'm putting it here on this diagram is just to give you the complete story, going from easiest import to most challenging. So we're not in this case yet, but we will be very shortly. This is the import statement we would write if we want to import something or import a file that is inside of our lib directory into another file in the lib directory. So for example, if I wanted to connect the prompter.dart file here to the terminal.dart file, these are both inside the lib directory. And so to do that, we again get a pretty easy import. We write out the import statement, the file name, and then the file extension of .dart. So for example, if I was in this terminal.dart file and I wanted to import all the code inside of option.dart, I would write import option.dart like so. And that's it. Very straightforward. So now let's go on to the third case. This is the case that we're in right now, and this is where things get really hairy. So because we are importing something from the lib directory into a file that is outside of lib, that's what we're doing here. So we are inside of main.dart and we want to import something from the lib directory, we fall into this third case. So the syntax here is significantly different. To do this import, we're going to write import the word package, okay, so the word package, a colon, then our package name. Our package name in this case is whatever name you used inside of our pubspec.yaml file. So if I open up my pubspec.yaml file right now, we put that name property in here, remember? And so I have prompter.sg, and remember I told you that you should have something unique and different from me. So whatever name you put inside of here is your package name. So we'll write out package, colon, your package name, and then a slash, and then the directory or the path to the file inside of your lib directory. Okay, so again, this is a little bit confusing. We went from the most simple import up here down to the most complicated one. So the import statement that we're talking about right now is when we want to get something from the lib directory to a file outside of it, which is what we're doing with example, trying to get terminal.dart. So to do that, we're going to write package, colon, our package's name, a slash, and then the path to the file that we are trying to import. So for example, for me, I would write out inside of my main.dart file, inside the example directory, the word package, a colon, my package name, which is prompter_sg, and then the path to the file that I'm trying to import inside the lib directory. So I would write out src/terminal.dart. Notice that I did not put the word lib inside of here. So it is assumed that when we put the word package here, that we are trying to look for something inside the lib directory. So I did not have to write out the word lib or put that into the path at all. All right, so like I said, gets a little challenging here, and when you first write out these import statements, you'll probably get a little bit frustrated, but once you kind of get a handle on this, it's pretty reasonable. So now that we've looked at this diagram, let's open up our main.dart file in the example directory, and we're going to try to write out this import statement. So inside of main.dart, this is a file outside of the lib directory, and we're trying to import something from the lib folder. So I'm going to write import package : and then I'm going to write out my package name, which is prompter_sg. Again, you're not going to write this, you're not going to write prompter_sg, you're going to write whatever name you are using. So I'll write prompter_sg, /, and then the path from the lib directory to the file that we're trying to get access to. So for us, it's src terminal.dart. So src terminal.dart. And then I'll put a semicolon at the very end. Now, don't pause here. Don't pause. You'll probably notice that it's still red. It says here target of URI does not exist. So the issue with this is that we have not yet kind of done all the tooling around our project just yet. We've got this pubspec.yaml file right here, but we have not yet had it processed by Dart. So to kind of complete the step here, we're going to go through the step and I'll tell you what we're doing. I'm going to come over here to the pubspec.yaml file. I'm going to right click it, and then if you're in Dart, you will find a selection that says Git Packages. If you're not, or excuse me, if you're using VS Code, you'll find a selection that says Git Packages. If you're not using VS Code, that's totally fine. I'll show you a workaround in 1 second. So if you're on VS Code and you see Git Packages right here, just click it, and I'll see my terminal appear. It tries to retrieve some dependencies. You'll notice that this .packages and pubspec.lock file were just automatically created, and now my import statement has been successfully resolved. Well, it still says unused import, but it's no longer showing the error saying that this package doesn't exist. All right, so a couple things to talk about here. First off, I want to show you a workaround in case you're not using Visual Studio Code, or in case you do not see that Git Packages selection right here on your pubspec.yaml file. So if you did not successfully run the step I just did, you can flip over to your terminal. You're going to change into your project directory. So I'm inside of prompter right now. And then inside of your project directory, you're going to run pub git, like so. Pub is a tool that is installed automatically when you installed Dart a little bit ago, like when we installed Dart maybe 10 or 12 sections ago. So you should be able to run pub git. You'll see a message like this appear on the screen, and then you should be able to go back to whatever editor you're using and see something similar to I. If you still don't see this, try restarting your editor, and then hopefully the import statement will be resolved. Okay, so very quickly, I want to tell you about what just happened when we ran that pubget command. When we ran pubget, that is the Dart package manager, it processed our pubspec file, and it downloaded all the dependencies required by our project, and set up the .packages and pubspec.lock files. Now in our case, we have no dependencies. So all that command did was essentially register the name of our project right here. So if I now open up the .packages file, you'll notice that there's this prompter_sg : lib right here. So this is kind of telling Dart and telling the tooling inside of our application that, hey, there is a package called prompter_sg, and it exists inside of our project directory right here, and all the files relevant for that project or for that library are inside the lib directory. So that's how this import statement right here ends up getting resolved. It makes use of that .packages file. Okay, so this was quite a crazy section. Definitely dumped a lot of knowledge on you. Hopefully it wasn't too much. Let's take a pause right here. We're going to come back to the next section. Now that we've got this import statement right here successfully put together, we'll try testing out our terminal code inside of the main.dart file. In the last section, we hooked up our terminal.dart file to the main.dart file through quite a series of different steps. So now we're ready to test out the terminal class inside of main.dart. Now before we do, I want to give you one quick thing here. Remember that when we imported the IO module right here into our terminal.dart file, everything that was declared inside of that IO module automatically got added into the same scope as this file. So we were able to simply reference standard out right here without having to say like IO module or anything like that. It just took everything that was declared inside the IO module and added it directly into this file. If we wanted to, we could optionally namespace all that stuff by writing out as IO, and then we would have to write out io.standardout right here. But if we just write the import statement, no namespacing occurs, and everything inside the IO module gets added to this file. Now the same thing happens when you and I import one of our files into another file. So now that we've imported the terminal.dart file into main.dart, every variable and every class that was created inside the terminal.dart file is added in to main.dart. So now inside of main.dart, we can reference that terminal class by simply writing out terminal, like so. So by writing out terminal, this is getting access to the terminal that was created inside of terminal.dart. Now, if we wanted to, we could again make use of that kind of namespacing feature. We could write out as like, I don't know, t, we'll just do t, whatever. And then we could do t.terminal. So optionally, we can still namespace stuff if we want to. Okay. So now inside of our main function, we're going to create a new instance of the terminal class by writing out var terminal equals new terminal. So this creates a new instance of the terminal class, and then we will call the print prompt method on it. So we'll do terminal.print prompt, and this thing expects to be called with a string. If I mouse over it, it gives me that quick reminder right there. Yeah, call this thing with a single argument that's of type string. And so I'll put in here, hi there, like so. And then I'll save the file, and we'll flip back over to our terminal and try running this thing. So I'll go back over to my terminal. I'm again inside my project directory. I'll change into the example folder. And so now inside of here is the main.dart file. And so I can run dart main.dart, and I see hi there appear. Okay, so this has been a lot of work to essentially get back to just the same print statement of hi there that we had before. But hey, we've got a lot more knowledge about import statements and all that kind of good stuff now. So we've kind of broken through a couple of walls here, and we're now ready to really accelerate the development of our terminal class here. So let's come back to the next section, and we're going to start working on our next method on our terminal class. So quick break, and I'll see you in just a minute. In this section, we're going to start working on our clear screen method. So we're going to skip over print options and collect input for now, and go straight to clear screen, because I think it's going to be a little bit more interesting. So the idea behind clear screen is we want to call this method to automatically clear all the content on our terminal window. So we can show just our question right here, along with the options for it. Now the process of clearing a terminal window varies depending on your operating system and the type of command prompt that you're running. So if you are on Windows and you are running the command prompt, or you are running PowerShell, to clear out your terminal window is slightly different than if you're on Mac OS or Linux and running like Bash or Z Shell, as I am. So we essentially need to do some type of check inside of our code to decide what type of operating system the user is running. And then depending upon whether they are on Windows or not, we're going to run some slightly different code in an attempt to clear out the terminal window. So the first thing we need to do is figure out exactly what operating system our user is running. To accomplish that, we're going to go back to our IO library documentation. And on the right-hand side, we're going to scroll down a little bit and find the platform module right here. So in the platform module, we're going to scroll down just a little bit, and you'll find a section here called Determine the OS. So as you might guess, this is essentially exactly what we want to do. This platform class has a couple of different properties tied to it that tell us very plainly whether or not we are on a given operating system. So if we are on Mac OS, this will be true right here. Otherwise, we can work with is Linux or is Windows. These are all Boolean values, so we can write out an if statement and then check the value of each of these properties and then write some different code to be executed depending upon what operating system our user is running. So let's write out some code to at least check what operating system our user is on, and then that will give us the ability to write some or to run some different code. I'm going to flip back over to my code editor. I'm still inside of my terminal.dart file. And then inside of the class terminal, I'll add a new method called clear screen. Now when I call this method, I definitely do not expect to return any value from it. So I'm going to annotate its return type as void. And we definitely don't need any other arguments inside of here as well, so I'm not going to add in any arguments. Now inside the method itself, we're going to check to see whether or not the user is on Windows first. So to do so, I will write out if platform.isWindows, like so. And then if the user is on Windows, we will run some code right here to clear out their terminal window. Now this is the first time that we've written out a if statement in Dart. We didn't really go over if statements before in great detail because, as you can see, it's basically identical to any other if statement in any other programming language. We write the keyword if, a set of parentheses, a check, a Boolean check right here, and then the body of the if statement. And then optionally, we can also tack on an else case as well. And you and I are going to want an else case for this if statement. Okay, so now inside of this if statement right here, we're going to check to see if the user is running the Windows platform. If they are, we'll run our code right here to clear out their terminal, the command prompt or the PowerShell. And then otherwise, we'll take care of Mac OS and Linux right here. So let's take a quick pause. We'll continue in the next section, and we'll first tackle this is Windows case. So quick break, and I'll see you in just a minute. In the last section, we added in a check to see what operating system the user is running. The assumption here is that if the user is on Windows, they are running either the command prompt or PowerShell. If you personally are on Windows and are on any other type of terminal or shell, well, unfortunately, what we're going to write here might not work out for you. I would love to do a more comprehensive solution here, but honestly, clearing out the screen is kind of not the most important thing for what we're trying to achieve inside this course. So let's do the best we possibly can. Now, to clear out the screen, we're going to essentially try to print out a very special character to the terminal. When the terminal sees this very special character, it's going to respond by clearing the entire terminal window. Now, unfortunately, the code or the kind of character that we're going to try to print out is kind of long and confusing, but we'll do the best job we can. So inside this case right here, I'm going to call standard out, which remember is the way in which we print out information to the terminal, and then we're going to call the write method. Previously, we called write_ln. Write_ln up here attempts to write out a string and then inserts a new line character at the very end. The write method right here just prints out a character all by itself, which is way more appropriate for clearing the screen. If we were to call write_ln, it would clear the screen and then start us off with an empty line above, which is not quite what we want. Okay, so let's take care of this. So we're going to pass in a string, and this is going to be a nasty little string. So bear with me as best you can. I will say that I will copy paste this string into the next lecture as a text lecture. So if you want to just go straight to the next lecture and copy paste that, it might be the easiest way. So inside of here, we'll do x1 capital B. We'll do a square bracket 2j backslash x1b, another bracket 0f. Okay, so essentially this is again, special character that will clear out the terminal window. So that should take care of us for Windows right here, and I will put this string right here in a text lecture in the next section, so you can just go copy paste it if you want to check your work. So let's save this, and we'll continue in the next section by taking care of the case in which the user is not running Windows. In the last section, we added in some code to clear out a Windows console. We're now going to handle the case in which the user is not running Windows. We're again going to write out a pretty strange little series of characters. I'm going to make sure that I paste this exact string of characters inside the next lecture as well. So if you don't want to write this out, that's totally fine. Just go to the next section and I'll give you something you could copy paste. Otherwise, let's do it together very quickly. So I'll say standard out dot write. In this case, I'm going to do backslash x1b. I'll do a square bracket 2 capital J, another backslash x1 capital B, square bracket 3 capital J, backslash x1 capital B, square bracket capital H, like so. Okay, so again, feel free to go to the next lecture and just copy paste this into your code, and I would almost recommend that just to make sure that you get the exact correct string of characters here. So I'll now save this file. We'll continue in the next section and we'll test out this code. We've now got some code put together to clear out either Windows or any other operating system. So let's now test this out. I'm going to open up my main.dart file. And then inside of here, I'm going to add a new call to my terminal instance right above the print prompt, and I'll try calling clear screen, like so. So now we should be able to go back over to our terminal and run this main.dart file. When we do so, we should see everything clear out and then see the message "Hi there" appear. And then since our program does absolutely nothing else, we'll probably be kicked back to the terminal or our command prompt after that. Okay, so I'll flip over to my terminal. I'm going to make sure that I'm inside of my example directory again. And I'm just going to get a couple of lines here on the screen just so I have something to actually clear out. Then I'll run dart main.dart like so, and I'm going to expect to see all this stuff get cleared out. Cool. All right, that's exactly what we wanted. All those other lines got cleared out, and we got our text by itself printed on the screen. And then, like I said, at this time, our program is doing nothing else, which is why we got kicked back to the command prompt. But eventually, we're going to have it so that we display our list of options or the list of questions, and then make sure a user has the ability to enter some input. So we've now got our clear screen method put together. Let's continue in the next section. We just put together our clear screen method. So let's go back to our list of methods that we need to implement and move on to the next one. We still need to do print options, which should probably take a list of option instances and somehow print them out to the screen. But we've not yet really created or worked on this class that much. So let's take care of collect input, and then we'll be able to kind of wrap up terminal class just as we start to work on this option thing as well. Okay, so collect input. The idea here is that we're going to have a function that watches for a user to enter in some text right here, next to the little kind of carrot looking thing. So we need to somehow retrieve some input provided by the user. Remember that we've already spoken a little bit about how we're going to communicate between our program and the terminal. Let me clean up this diagram. There we go. So to send information over to the terminal, we're going to make use of standard out, which we've already wired up. To get information back from the terminal to our program, we're going to be making use of standard in. So standard in is how we receive information from the terminal. As usual, let's very quickly open up our I/O documentation and take a look at standard I/O. Now, first off, let's go to the very bottom of the classes section over here. You'll notice underneath the properties section, we see that there's a lowercase standard in right here as well. So just like with standard out, this I/O library automatically created an instance of standard out for us. The same thing is true of standard in as well. So this is an already created instance of the standard in library, or excuse me, the standard in class. So that's the property right there. If we scroll up a little bit, we'll find the standard in class documentation right here. So we'll take a look at that. Okay, so on this page, we'll scroll down a little bit and find our methods section. Here's methods right here. And you'll notice that one of the methods that's available to us is readLineSync. So when we call readLineSync, it's going to synchronously, and we'll talk about what that means in just a second, read a line from standard in. And that call is going to block until a full line is available. So the term synchronously right here, and the second sentence of this call will block until a full line is available, means to say that our entire program is going to be paused for just a little bit as we wait for a user to enter in some input to our program and then press the enter key. Specifically, the word right here, read line, means that we're going to wait until the user presses enter. And so this really suits exactly what we're trying to do, because we want to present our user with a question of sorts right here, and then just kind of wait around and just sit right here and wait for them to enter something and then press the enter key. And at that point in time, we'll take that input and we'll know what to do with it. Okay, so let's go back over to our code editor. I'm inside my terminal class right here, and right above clear screen, I'll define a new method that I'll call collect input. Now collect input, probably not going to require any arguments to it. However, collect input, well, it definitely sounds like we want to retrieve some information and probably return it from this method right here. So if we go back over to that I/O documentation very quickly, you'll notice that on readLineSync right here, you see the little arrow over here on the right-hand side. So the arrow means to say that this function returns a string, and the string is whatever text our user enters in at the command line. So rather than trying to process the response from the user inside of here and say, okay, the user just pressed 1 or 2 or 3 or anything like that, the sole purpose of our terminal is to take that input from the terminal and then relate it back over to some other part of our program, most likely the prompter class, which you'll recall is kind of like the facilitator or the broker of all these questions that are getting asked. So in short, I think that the collect input method right here will probably return a string. And inside the body of this, we will simply call return standard in dot read line sync, like so. So now the instant that we call collect input, we're going to invoke read line sync right here. We're then going to pause execution of our program until the user enters some text and presses the enter key. When that happens, this read line sync method right here will return whatever text the user just entered, and then we will in turn return that from the collect input method. So now we can make use of collect input from maybe the prompter class or wherever else we want to actually make use of this thing, and we can figure out what answer the user is providing to us. Now as the last step, we will flip back over to our main.dart file, and inside of here we'll do a quick test. So I'm going to say, how about right after terminal.print prompt, we'll add in a call to terminal.collect input. So we'll call that. This is going to return a string right here. So I'll save that to a variable that I'll call simply input. And then how about we just print out the input? Let's just print it out, and hopefully we'll see whatever text we enter. And actually, you know what? Let's try to make this a little bit more clear. I'm going to wrap it with a string, and we'll say you just entered, and we'll put a $sign on input so that we can do our string interpolation. Okay, so let's save this, and then we'll flip back over the terminal and test this out. So back at the terminal, I'll make sure I'm still inside my example directory. I'll run dart main.dart. We see hi there, and then you'll notice that unlike before, our program just kind of pauses and sits here, because now it's waiting for us to enter in some text on standard in. So I'll enter in something like, hey, how's it going? And you'll notice that as I type, still nothing's really happening with the program. We see our text appear right here, but it's not instantly taking our input and then continuing on with the program. It's waiting for me to press the enter key, and only when I do that is that line right here, read line sync, going to finally return and say, okay, here's what was entered. So again, this waits for the user to press the enter key. That's what's implied by this read line name. Okay, so now I'll go back over, I will press enter, and then I see you just entered, hey, how's it going? And there's nothing else for our program to do, and so it exits back to the command line. Awesome. So this is some very good progress. We're now able to get input from our users, and we've got kind of the makings of our program here. We're not too far off at this point. So let's take a pause. We'll come back to the next section, and we're going to start thinking about how we're going to implement our remaining method of print options and how that's going to make use of the option class thing over here as well. So quick break, and I'll see you in just a minute. In the last section, we finished up on our collect input method. In this section, we're going to pause working on our terminal class. So the last thing we have to work on is the print options method. Print options is presumably going to take a list of option objects and print them out to the terminal. But we still don't really know anything about the implementation of option class right now. So we're going to kind of do a brief detour, figure out what the option class is going to do for us and how it's going to work. And then once we've got that put together, we'll go back over to print options and finish up the implementation. So in this section, let's talk about what the option class is going to be doing for us. In particular, what different fields it should have and what different methods it should have. As a quick reminder, that option class is meant to represent every selectable option on a single question. So this right here would be an instance of option, and this right here would be an instance of option. So we need to think about the different methods and properties that would be tied to the class that kind of represents this thing right here. Now, I'll be honest with you. I was trying to think about different methods or different pieces of functionality that I would want to tie directly to that option instance. and I'm kind of having a really tough time of thinking of any methods at all. I really can't think of a single method that I really want to tie to the thing that represents this particular line item or this possible selection. So I think this might be a class that doesn't really have any methods tied to it, at least right now. Maybe we will think of something later. So let's move on to the properties. What different properties or what different fields would we want to associate with that? Well, when I look at this, there's definitely some text that needs to eventually be represented on the screen. So I think that it's fair to say that on the option class right here, we will have at least one field. So let me put my field notes on here. So we'll get a name and a type, something to represent the kind of text that gets displayed on the screen to the user. I think a reasonable name for that would be something like label, like this is the label of this option. And since it's supposed to be a string of characters that gets printed out at the terminal, I think it definitely makes sense to make that label of type string. Okay, so that one's pretty easy. That one's not that bad. Now, I'm looking back over here again, and I'm wondering if there's any other fields that I want to associate with this. And you know what? There actually might be. I want you to take a look at this question right here. So it says, what color should we use? And then we get the selection, red or blue. Now, given this question right here, and given the two possible answers, I think that you can kind of imagine that if I selected one right here, it's really obvious that I want to select red. And like you and I, as developers, could write some code to see, oh, this user just selected an option that has a label of red. We're going to use the color red for whatever like nefarious deeds we're trying to accomplish here. However, if we instead had a label of something like, I choose the color red, well, then it makes things a little bit more challenging for you and I as developers. If someone selects number one right here, how are we going to like understand this or kind of derive some meaning out of it? Life just gets a little bit more complicated. Let me give you a good example of why using the label right here might not be good enough for having it represent the entire option object. So the string, red and blue right here, you and I as humans can very easily interpret. We see red and blue and we immediately think of the appropriate colors, red and blue. However, a lot of software that we make use of do not understand the string red or blue. Instead, a lot of software that we work with understands hex codes to represent colors. So this is a hex color picker right here. You'll notice as I drag around the screen and change the color, this value right here is changing. So this right here is a hex code representing the color that I'm picking. Hex codes like this are very commonly used to represent colors inside of computer programs. And so thinking back to this kind of color selection wizard right here, maybe if the user chooses option number one right here of I choose red, if we got back literally the string I choose the color red, that's not really super useful for us. We might have to then take this string and somehow parse it to understand that the user picked the color red. So a much easier way of kind of implementing this and getting some good functionality out of it would be to add a second property to our fields object right here. I'm going to call this second property value. So value is going to be some arbitrary piece of data that a developer like you and me can add in to a particular option. So we can show a label of something like I choose the color red, and if a user selects that option, we will be able to look at this value property and understand that the user meant to say like the color code #F00, which is the hex code for red. Now, as I'm talking through this, it might not make any sense whatsoever, and just between you and me, I've now recorded this section like 5 times trying to explain this better. I'll be honest with you. This is one of those things where it might not make a lot of sense to have both a label and a value on here just yet, but trust me, the instant we start actually making use of these classes together, you are going to understand why we have both a label and a value. So this is one of those things where if it doesn't make sense right now, just wait until we finish the whole example and it will make a lot of sense, trust me. Now, last thing we have to do is pick out a value type for this value property. So you and I, as developers of this kind of open source library, we don't really know what type of value a user might or a developer might want to assign to this thing. In one case, they might be trying to get a color pick from a user, and so maybe they would want to store a value of a hex code. But in another case, they might be trying to have a user select like a file object. And so the value might need to be of type file. Or in another case, it might need to be of type double or int, or who knows? We really have no idea. So because you and I can't really predict the type of this value field right here ahead of time until a developer actually makes use of this library we are creating, we are going to assign a type of dynamic. You'll recall that type dynamic right here essentially represents all types in Dart. So by assigning a type of dynamic to value right here, that means to say that we can assign any type to this value property, which is going to make our option class right here extremely flexible and very reusable. Okay, so that's our option class. Let's take a quick pause right now. We'll come back to the next section and actually put together the implementation of this thing. So quick break, and I'll see you in just a minute. In the last section, we spoke about our option class fields. So we ended up saying that we're going to have a label of type string and a value of type dynamic. So let's now flip over to our option class, and we're going to add these fields to it. Okay, so back over here, let me open up my Explorer, and I'm going to find my option.dart file inside the src directory. So to the option class, I'm going to add on two properties. I'll say string label, and I'll also add on dynamic data, like so, or excuse me, not data, value, my mistake. Now we need to make sure that when we create a new instance of the option class right here, we have the ability to set the value of label and value. Because the instant that we create a new option, chances are we want to make sure that these two properties get set right away, so the option is ready to be used. So we're going to define a constructor function on this thing, and we're going to use the shorthand syntax for getting the provided label and value inserted into these two properties, or these two fields right here. So I will write out option, and we'll say this dot label and this dot value, like so. So now when we create a new instance of option, writing out something like new option, my color is red, then we could provide the value as the second argument, which would be our hex code of something like #F00 to represent the color red. So now because we are using the this dot property name syntax, my color is red will be automatically assigned to the label, and #F00 will be automatically assigned to value. Okay, so that's pretty much it for this thing. So I think we're just about set with the option class right here. Now, I had said previously that we probably will not have any methods assigned to this thing. You know, I'm kind of joking about that just a little bit. Maybe we will come back to this thing and add on one or two quick methods, but we'll figure out whether or not we actually need to do that in a little bit. So let's take a pause right here. When we come back in the next section, we're going to go back to the terminal class and start working on the print options method. So quick break, and we'll take care of that in the next video. Now that we've got our option class put together, we can start working on the print options method back inside the terminal. So remember, the idea here is that we're going to create a list of option instances, then feed them into print options and expect them to get all printed onto the screen. So let's get to it. I'm going to get started by opening up my terminal.dart file. So here's the terminal class. Inside the class itself, I'm going to create a new method that I'm going to call print options. Print options is going to put some stuff onto the screen. So I don't really expect it to have to return any value. So I'll mark it as void, like so. And then I definitely expect this thing to be called with a list of option instances. Remember, a list in Dart is very similar to an array in just about every other language out there. So as an argument, I'm going to say that I expect this thing to get a list, and every element in that list should be of type option. And I will refer to that argument as options. And you'll notice that the option designation right here has the squiggly red line, and it says the name option isn't a type, so it can't be used as a type argument. So the issue here is that we are inside of our terminal.dart file, and we are trying to make reference to code that has been placed inside of a different file. Remember, anytime that we want to get access to code inside of another file, we have to specifically import it over. So let's go back to our diagram of the different ways of imports, and we'll figure out how we're going to write out this import statement. So this is where we fall into case number 2 right here. We are trying to import something from the lib directory into another file in the lib directory. When that's the case, we can simply write out import and then the file name that we're trying to import. So back inside of terminal.dart, I can write out simply import option.dart, like so. And then the error message goes away. So you'll notice, yeah, this was an easier import statement to write than the other one that we just had to do inside of the main.dart file. So when you are getting files that exist inside of your own package or your own lib directory, life is pretty straightforward, not too bad. Okay, so we've now got our list of options in here. We now need to iterate through this list of options and write something out to the terminal for every option. This is going to be another case where we make use of the standard out.writeLine method to communicate some information over to the terminal. But first, we need to figure out how we're going to iterate through this options object. We're going to first begin by writing out kind of the very straightforward, very simplistic way of iterating through a list that chances are you are very used to doing already. So we're going to iterate through the list of options by using a simple for loop. A for loop in Dart, is just about identical to a for loop in, many other languages, many others. So we write out for, we write out our set of parentheses, we then write out a temporary variable. So this is going to be a counter variable of sorts that I'm going to start at 0, and I'll call it I. We're then going to iterate through the options loop or options list as long as I is less than options.length. And then every step through the for loop, we will increment I by 1. So if you've ever written JavaScript, yeah, we could basically copy paste this loop over to JavaScript and we would be good to go. It's completely identical syntax. So now for every option in the options list, we can call the standard out writeLine method. So we'll do exactly that. We'll say standard out dot write ln. And then inside of here, we're going to look at the particular option object that we are iterating over, and we will print out its label property. Because remember, that's what we care about here. We care about its label. That's what actually gets displayed to our users, the label. So now I will print out, and we'll do a little bit of string interpolation here. So I'll do $, options, and then to reference a particular element within a list, we use this square bracket syntax, just like many other languages. Again, no big surprise here. And then we'll specify the index of the element that we want to look at. And then we want to select the label property. Now, one quick thing. Remember that we've said that we use the $sign for doing string interpolation? Well, $sign is used when we are interpolating a single variable or just listing out the variable. If we have any type of logic inside of that interpolation, which we do right here, we have to use those curly braces. So this is an example where I'm going to wrap it with curly braces. Okay, now as a quick reminder, on every single line that we print out, we also want to show the number of the option, so like 1 or 2 or whatever else it might be. So just to kind of decorate this line a little bit more, I'll give myself a space at the start of the string, and then inside of a pair of square brackets, I'm going to put $I, and I'll put a dash in between as well. So the square brackets right here are not any type of meaningful syntax. This is just going to end up giving me some notation that looks like, 0, 1, and then we would have a dash, and then like my color is red and my color is blue. That's essentially what we're doing with this string right here. Okay, so that's pretty much it for now. Now, the last thing we have to do, if we go look at that mockup one more time, you'll notice how we also say on here, enter a choice, and then we show an empty line, and then we also print out the little caret right there as well. So we're going to take care of that inside this print options method as well. So after we loop through every single option and write them out, we'll then do a standard out dot write line, and we'll say enter a choice. We'll also append a new line character to the end of it, so that's going to give us the extra space that you see right there. So we'll do \n, and I'll do standard out dot write just right this time because we don't want the extra line, and we'll do the caret. So if we did write line, then the end result would be that we would print out something that looks like that, and then the cursor would be blinking right here. So we definitely don't want write line's extra new line character. We want just write by itself, so we print the caret and then leave the cursor right there. Okay, so that's pretty much it. Let's get the semicolon on there, and I think we look pretty good. Now, this section's ran a little bit long, so let's take a pause right here. We'll come back in the next section and test this print options method out. In the last section, we wrapped up our print options method, and now we're ready to test it inside of our main.dart file. So I'm going to flip back over to main.dart. I'm going to first get started by cleaning up some of this test code that we have inside of here right now. So I'm just going to delete all that. And then we're going to first create a list of options and then feed that list of options into the terminal.printOptions method. In order to create the list of options, we need to make sure that we first import the option file into the main.dart file, because right now we have only imported in the terminal.dart file. So at the top, I will import package. I'll do my package name, which for me is prompter SG. For you, it's very likely going to be something different. I'll do /src. And then we're looking for the option.dart file. So now inside of my main function, I can create a new list of options that will eventually print out to the terminal. So I'm going to make a new variable called options, and I'm going to have it be a list. And then inside of here, we will create all the different options that we want to have printed out. To make a new option, remember what we do, we're going to call that option class. We're going to call its constructor by using the new keyword. So I'll say new option. The first argument to this thing is going to be the label that gets displayed to the user. So we'll make that I want red. And then the second argument is the value. And the value in this case is going to be like the programming side representation of whatever the user just picked. So to actually carry this color theme through, I'll use the hex code of red, which is #F00. We'll do our comma, and then we'll make one more option. So this will be I want blue. And the blue color code is, let me get over there, #00F, like so. Okay, so that's looking pretty good. So now the last thing we have to do is take this list of options and pass it off to the terminal.printOptions method. So at the very bottom, we'll do terminal.printOptions. And now we will pass in our list of options. All right, so I think that we're all set here and we are ready to test this. So I'm going to save this file and we'll flip back over to our terminal. I'm going to make sure I'm inside my example directory still, and I will run dart main.dart. Awesome. So now when we run it, I see 0, I want red, 1, I want blue, and then enter a choice. We then print out the caret right there, and then presumably we would enter either, a 0 or a 1 to select either red or blue. Now at this point in time, we are not actually calling that function of collect input right here to actually solicit some feedback from the user. So maybe just to get kind of a complete example here, let's try calling collect input as well so that our program does not immediately exit, and we could actually enter in a suggestion or an option. So after calling print options, I'll call terminal.collect input. And you know what? Why don't we make this like a fully featured example? Let's take whatever text the user enters right here. We'll assign that to a new variable that let's call, how about response? That's fine. And then after we get the integer that the user responded with, we'll just print it out. And I say integer, but collect input right here actually returns a string, to be precise. So we'll just print out whatever the user whatever the user selected. Okay, so let's try this test again. I'll save the file. We'll do dart main.dart. There we go. So now here, this is looking good. We printed the options, we're asking the user to enter a choice, and then the program is just paused, waiting for us to enter something. So in this case, I'll say, I want 0. So I enter 0, I hit enter, and then we print out the feedback or the selection that the user just made. So I don't know about you, but it sure feels like we are getting pretty darn close to getting this thing working. And in fact, we actually, we are rather close. So let's continue in the next section, and the last big thing that we have to work on is our last class, which is the prompter class. So let's start talking about the prompter class in the next section.